Well, good morning, everybody. We are going to be doing some notes today on Chapter 1, Section 7, the distributive property. So you may have noticed that in your homework from the last section, at the end of it, there was a few distributive property questions. I'm not sure how that got on there, but we'll work through it. Okay, so again, like always, vocabulary is key in math. We need to know and use proper terminology when we're talking. So our new definitions that we are bringing in is the definition of what is a constant and what is a coefficient. Okay, so a constant is when we have expressions. In expressions, there sometimes are terms that do not have, they have no variable in them. That is a constant. So it's pretty much, it's the number, whether that number is a fraction or that number is a decimal or that number is just a nice whole pretty looking number. That would be your constant. It's the term that does not have any variables. Coefficients, we talked about this a little bit in the last set of notes, but it is the number in the term. So it tells you how many of the x's or n's or whatever it is there are of them. So an example of that, if you wanted to see one real quick, would be like 3x. The 3 is the coefficient of the x term. It tells you that there are 3 x's there. We can distribute in two ways. So this entire section is talking about being able to distribute something. The two forms that we have, they're both, it's a form of multiplication. So when we get really good at it, we have the normal, you can computationally do it. Then there's also the area model. So area model is what's really good when we're first starting out. Computationally is the way we will always do it once we get good at it. So let's first take a look at what's going on computationally. If you have this expression 3 and then in parentheses, remember there, because it sits right next to it, there's technically a multiplication dot right there. So you're multiplying it by all this stuff inside of the parentheses. Well, consider this to be like you, like your brother and your sister, okay? And your parents are giving you guys $3 a piece. You cannot give $3 to one sibling and not the other. It's not fair. So this is exactly how this works here. If you have a 3 sitting outside and it's being multiplied, you have to multiply it to each one of the pieces or the terms inside of that set of parentheses. So one term is 3x, so to rewrite it, your next step will be 3 times 2x, put it in its own set of parentheses, plus, because the plus separates the two terms, and then you do it again, 3 times 1. Okay, so 3 times 2 is 6, and the x comes down, and 3 times 1 is 3. There you go. You just did your very first distribution here. All right. How does this look like if we compare it to the area model? Okay, so the area model, this is something if you're not really used to this, the area model is really good for you. So in the same thing, we're still distributing, but they set it up so it's visually easier to see. So you have a one term, here's one term, and there's 2 terms in here, right? So we make a box that's width is 1, and the length here is 2. So it's a 2 by 1 block section. Each of these up top get written down above, so 2x gets written here. Because it's positive, 1 or plus 1, we just write a 1. Outside of the parentheses is a 3. Now, to fill in these particular spots, we do a little multiplication. So we multiply to get into the box, we add to get out of the box. So 3 times 2 is 6, and the x comes down. 3 times 1, because that's what lines up vertically and horizontally here. 3 times 1 is 3. Now we added to get into the box, or multiplied to get in the box. Now we add to get out of the box. So 6x plus 3. And we ended up with the same thing here. 6x plus 3. Sometimes when you're learning two different ways, it's good to use the exact same problem so you can see the different paths to get to the same result. So from our original equation, 3 times 2x plus 1, 3 times 2x plus 1 is equivalent or equals 6x plus 3. These two statements here are called equivalent statements. It means the same thing, that they equal each other. They're just represented in a different way. This is a factored version of that that particular one. Let's look at distributing a negative. Sometimes you're going to see a problem like this and they want you to simplify it. And what they're really wanting to do is take a look. Notice that this right here is not a plus sign. This is the #1 way that they like to trick us on our EOC test. Just because it's a minus sign, there is technically, it's a -1 here. This -1 has to be distributed. Okay, we must multiply every single thing inside of this set of parentheses by -1. So if we do that, this just carries down because we don't do anything with this. -1 times 3 is a -3a. -1 times -4 becomes positive 4b. And now as we sit here and we look at this, well, we have to collect our like terms. We have a's are the same. And we have the b's are the same. And that's all we have to do is now collect our like terms. So if you have 2a's and minus 3a, you have a -a. And if you have a positive 4b plus a 4b, so 4 plus 4 is 8b. So this entire expression here is equivalent to -a plus 8b. And you're good to go. This is the #1, again, guys, #1 trick. On that EOC test, #1 trick. They like to do this because a lot of people remember to distribute to the first one, but then they forget to carry it out to the second term as well. Please, please, please make sure you're being careful. Now, here is another one, and this one is not as bad. We are still distributing a negative, but this time there's actually a value other than 1. So sometimes it's easier to see this particular one. So we see here the -3 is what has to be distributed. So if we want to get technical, and now you also have on this side here a 2 that has to be distributed. All right, so let's distribute this 2. The 2 has to be multiplied to here. That gives you a 6x. This 2 has to then be multiplied to here. That gives you 4. The -3 gets multiplied here. So you have a -12x. And this -3 gets multiplied here to -6. A -6 times 3, a negative times a negative is a positive. Positive 18. Now all we have to do is do a little bit of combining like terms. In this case, look, we have variables that are the same. And then we also have some constants that are the same. So 18 plus 4, 18 plus 4, we're looking at 22. So now we've used these. And +6 and a -12. -6x. And so there's our equivalent expression. All of this big expression here can simplify by using distributive property and combining like terms to 6x plus 22. These are equivalent expressions. Doing the same thing using an area model. So again, we need to make sure we have our box drawn and we know what we're doing here. So we have one term outside the parentheses. There's 2 terms inside. So I can see by like this 1 term, 2 terms, we're going to need a 1 by 2 box. There we go, our 1 by 2 box. Now the side piece, the 1 spot here, that's what's outside the parentheses, -5. And inside is 6w plus 9. Very important. If this was a minus symbol, you would have had to make this -9 here. Okay? Make sure you're paying close attention to that. Now we do our multiplication, horizontal and vertical multiplication to get in. So -5 times 6 is a -30. W. -5 times 9. So again, you are change colors. We are multiplying horizontally and vertically. -5 times 9 is a -45. So if we are looking at equivalent expressions here, so we multiplied to fill the boxes in, we have to add these two terms together to get out. Well, look, we have a -20W and a -45. They are not like terms, so all we do is rewrite them. And those are equivalent expressions, these two expressions here. So area model, really good, guys, for visually being able to see what you're doing, starting how to learn it, getting ready to it. As you start to get better, then we do more of the standard distributive property without the area model. Either way works. That's up to you which one you like. Again, algebra, lots of different ways to get the same result. We do what we like to get the right answer. Have a good day, guys. Start your homework and have fun.